Hello and welcome to all participants from around the world. My name is Arya Peruma and welcome to today's webinar. Today I will be going over multiplying polynomials as well as introduction to slope, and today we'll be going over a few variations of these kinds of problems. Keep in mind that this session will be recorded and will be posted to our website shortly after the session, and the link to that is pasted in the chat and is also displayed on the screen you're viewing. So with this, let's get started with our very first question. And today we'll start with introduction to slope. Okay, so the very first question we'll be looking at today is find the slope between 3 and 1 and the point -2 and 1. So before carrying out these kinds of problems, I'm going to quickly refresh your memories, and if you don't already know, I'm going to be introducing you to a concept which is very important for solving a problem like this, and that is just basically what slope is. So I'm just going to over here, I'm going to write and explain a little bit about slope. So slope is usually represented by the variable m, and slope is basically another way of saying the change in y over the change in x. So I'm just going to write that down. So m, which is a variable which represents slope, is equal to the change in y divided by the change in x. And what I mean by this is just simply the change up the y-axis divided by the change down the x-axis. And we'll look further in depth into that when we actually solve these kinds of problems. Another way to write slope, other than change in y over change in x, would be delta y over delta x. So delta y over delta x, or delta y over delta x. And this little triangle you see over here basically represents the word delta, which basically means change in. So change in y divided by the change in x. So another way to say this is the equation for slope, or the formula for slope rather. And this is basically represented by m is equal to y2 minus y1 over x2 minus x1. And the reason for this is, as you can see, as I mentioned previously, that slope is actually the change in y divided by the change in x. And that's exactly what this equation of slope or slope formula is saying. It's saying the change in y, y2 minus y1, the second y coordinate minus the first y coordinate, divided by the change in x, which is the second x coordinate divided by the first x coordinate. And keep in mind, you can only use this formula or this equation for slope when you have 2 points given, like this question number 1, which I've written down. So now with this information, we are ready to solve and find the slope, and we're ready to solve for what this question is asking us to find. All right, so this question is saying to find the slope between points 3, 1 and -2, 1. And essentially, these points, 3, 1 and -2, 1, belong to a line. And these 2 points actually lie on a straight linear line. So we just basically need to find the slope of that line, or slope of that line between the points, between these specific points mentioned in the question. And that's exactly what we're going to be doing. So we know that slope is the change in y over the change in x. In other words, y2 minus y1 divided by x2 minus x1. I'm just going to write that out here, x2 minus x1, 1. x2 minus x1. And basically, what we need to do is we need to identify or establish the values of x1, y1, x2, and y2. So in order to do this, we need to take a look at our 2 points which are presented in this question. So first we have 3, 1 as point number 1, and then we have negative 2, 1 as our second point presented in the question. So in order to do this, we need to take a look at the first point they've given. They've given 3, 1 as our very first point. So to identify the values of x1, y1, I'm going to say that 3 is x1, and 1 here is y1, as this is our very first point given inside the question. So we can say that since this is the x value, 3 is the x value for this point, this is x1, and since y is 1, 1 is the y value for this point, we can say that this is y1. Similarly, looking at the second point given in this question, which is negative 2, 1, we can also easily identify for x2 and y2. So since negative 2 is the x value in this point, we can say this is x2 as this is the second point which is presented. So this is x2. And positive 1 here, which is the y value in this point, this is y2 as this is the second y coordinate point presented out of these 2 points here. So therefore, we've identified the values of x1, y1, x2, and y2. These are x1 is equal to 3, y1 is equal to 1, x2 is equal to negative 2, and y2 is equal to 1. And this is basically the hardest part of this question. It's just identifying your values. And now with this, we can easily find our slope. All right, so now finding our slope, we know that slope is represented by variable m, so I'm just going to write that here. And we know that slope is y2 minus y1 divided by x2 minus x1, or in other words, the change in y divided by the change in x. So we know that it does represent this, and using this, we can easily substitute our values which we've established earlier into this formula for slope. And this is basically the next line. I'm going to write m is equal to. So now let's take a look at our numerator. Numerator says y2 minus y1. And taking a look at this, we said y2, we established y2 as 1, and we established y1 as 1 in addition. So we have 1 minus 1 as per the slope formula. And then this is divided by change in x, in other words, x2 minus x1. And x2, we've established x2 is negative 1, so I'm going to write that down here. It's negative 2, sorry, it's negative 2, so I'm just going to write that down. And we have x1 here, and x1 is 3 as we've established, so minus 3. And okay, so now we have got our numbers and we figured out our numbers. And now what we need to do is we need to further simplify as we need the value of m, or in other words, slope. So simplifying, m is equal to, looking at the numerator, we have 1 minus 1, that is just 0. And this is divided by minus 2 minus 3. Minus 2 minus 3 is negative 5. And we have m is equal to 0. 0 divided by negative 5 is 0. And therefore, this is our slope of our line. So therefore, the slope of a line with coordinates 3, 1 and negative 2, 1 is 0. 0 is our slope. And just another thing to keep in mind, that when m is equal to 0, or in other words, slope is 0, this actually indicates a horizontal line. So this indicates a horizontal line. So this indicates this horizontal line. And the reason being is when there's a horizontal line, there's actually no elevation to the line, meaning that there is no slope, as it's just a straight horizontal flat line. So there's no elevation or slope to it. And that's why the slope is equal to 0. And that's why m equals 0 when slope is 0. It indicates a horizontal line. So therefore, the slope is a horizontal line. So there we have it. We have just solved our very first question involving introduction to slope. And now let's move on to a second question where I'll be introducing another concept which is also very important for questions like these. All right, so taking a look at this, we have for question number 2, we are told to graph the equation of 3x plus 4y equals 12. So as you can see, now in this question is asking you to do something a bit different. It's telling you to graph this line. So in order to do this, we have to keep in mind what we learned before about slope, but there's also a new concept I would like to introduce to you for this specific problem, and that is basically slope-intercept form. So I'm just going to quickly write this out. So slope-intercept form. And slope-intercept form is basically defined by y is equal to mx plus b. And this is not something complicated at all. This is just essentially a form of equation where linear lines can be written as, or to make it easier in this case, we were asked to graph the lines. So this slope-intercept form, this form of y equals mx plus b for straight linear lines, makes it really easy to locate points in order to graph it. And I'll show you how to do this. But first, I'm just going to quickly go over what these variables inside this slope-intercept form represent. We have y equals mx plus b. And there are two main variables you really need to know what they represent. And that is basically variable m and variable b. So taking a look at this, variable m, as I mentioned before, I said that it represents slope. Whenever you see variable m, it represents slope. So this is actually representing slope here. And now I said you have to also pay attention to variable b. And variable b just represents the y-intercept. This represents the y-intercept. And if you're not familiar with what a y-intercept is, it is basically when, say, I'm just going to quickly draw a rough sketch of a line here. Say you have this line. The y-intercept is the point where this line touches the y-axis. In that case, it'd be this point that I've marked a green dot with over here. And it's basically the point where your straight linear line will touch the y-axis. And that's what is called the y-intercept. So say that this line I've drew in red here actually touches the y-intercept when y is 2, at 2 on the y-axis. So then y-intercept is y is equal to 2. That is the y-intercept of this equation, or this line rather. So this is just a quick example, but we have to follow the similar concept for this question. So in order to figure out and follow through with this question, we need to be able to graph this. But as you can see, we have the equation of 3x plus 4y is equal to 12. And as you can see, this equation is actually not in slope-intercept form. It's actually very difficult to graph right now. And whenever you see an equation like this that is not in slope-intercept form, keep in mind that it's very difficult to graph it when you don't put it in slope-intercept form, as slope-intercept form, this form here, which I mentioned about y equals mx plus b, this form actually makes it really easy for you to be able to find points and graph them, which I will demonstrate later. But we need to put this specific equation into slope-intercept form. So in order to do this, as you can see, slope-intercept form says y equals mx plus b. So therefore, we need to isolate for y inside this equation given, this equation of 3x plus 4y equals 12. We need to actually isolate for y so we can put this into slope-intercept form from the standard form it is in currently. So doing this, we're just going to follow through with our simple algebra to be able to isolate for y by just isolating for y by first subtracting 3x on both sides. So I'm just going to quickly write this equation out. So we have 3x plus 4y is equal to 12. That is our equation. And now we have 3x minus 3x plus 4y equals 12 minus 3x. So now keep in mind, I just did simple algebra here, and just a refresher, I wanted to isolate for variable y, so attached to it was a plus 3x on the left side, so I subtracted 3x on both sides in order to get rid of the 3x attached to our 4y on the left side. So I performed the opposite operation. So likewise, we have on the left side now, we have 3x minus 3x, which is 0, they cancel out, is 4y is equal to 12 minus 3x. I'm just going to rearrange it and write minus 3x plus 12, as it is better to have your variable terms in front of your constant terms. So I just rearranged that there. And now we need to isolate for y even further. So what I'm going to do is I'm going to take a look at what is attached to y. We have y being multiplied by 4. So in order to get rid of it, we need to perform the opposite operation from multiplication, which is division. So dividing both sides by 4, going to be dividing both sides by 4. So 4y divided by 4, just simply y, that's equal to minus 3 over 4x plus 3. And I just did this because whenever you see multiple terms in the numerator being divided by one single thing in the denominator, you can divide each term in the numerator by that term in the denominator. And that is what I've done. I've done minus 3x divided by 4 plus 12 divided by 4. 12 divided by 4 is actually 3, so I've written plus 3 there. And therefore, this is our this equation, which was given in the original question, and we've just simply converted it into slope-intercept form. And now we're not quite done yet because we do need to graph this line. So I'm going to quickly show you how you would do this. So I'm just going to quickly draw a y and x axis, or x and y axis here, a coordinate plane. And using this, we are going to use this to actually graph this particular line here. So in order to do this, as I mentioned before, there were two key variables you need to know what they mean, and that was basically what m and b is. And as you can see, if you take a look at this equation we've derived in slope-intercept form, it is actually like very similar, the exact same rather, to y equals mx plus b, except they have numbers instead of m and b being the variables. So we have mx plus b is equal to y here, and we have minus 3 over 4, which is in front of x, just like m is in front of x inside slope-intercept form. So therefore, we can say that m is equal to minus 3 over 4, and keep in mind, I'm just going to quickly write this like this. Okay, m is equal to minus 3 over 4. As you can see, m is right in front of the x, and so is minus 3 over 4 here in this equation we've derived. And keep in mind that m does represent slope. So keep this in mind when we graph this line later on. In addition, we also have 3 here, and that's exactly like the variable b you see in slope-intercept form, and I said that b represents the y-intercept. So y-intercept is 3. So this line will for sure have a slope of -3/4, and the y-intercept, or rather the point where our line here crosses with the y-axis, will be when y is 3. And we know these criteria for our line just by taking our original equation, putting it into slope-intercept form. That is why it's so important to know slope-intercept form and be able to convert a standard form or another form of equation into slope-intercept form, because it makes it very easy to graph this way. So now that we've covered this, I'm just going to demonstrate how you would graph this. So what I'm going to do is I'm just going to draw these marks here, which indicate our units. And all right, so I've put those there. And now what we need to do is we need to take a look at what we have established. So the very first thing you want to do when plotting or drawing these kinds of lines is to locate your y-intercept first and foremost. So you want to locate where your y-intercept is. So we know that from this question, our y-intercept is 3. 3 is where our line actually crosses the y-axis. So we're going to plot that point. 1, 2, 3, going up 3. This is our y-intercept. This is that point where that our line actually crosses the y-axis. And that's what I've drawn here, this blue dot over there. So now using our y-intercept point, which we've marked, we know for sure that our line will go through this specific point. Using this, we are going to now carry out and plot the rest of the points on this line, or as much as we can with the space we are provided, in order to connect our points later on and make an actual line. And hence we'll be graphing it that way. So now, as you can see, now that we have our first half done, we've located our y-intercept, we said y is equal to 3, and we plotted that point right there. Now we have to take a look at our slope. So as you can see, the slope is actually negative, and that means that the line will be starting from the right, but it will be going down. It'll keep on going down rather than going up. So a negative slope looks like this. This is a negative slope, but a positive slope looks like this. So this is a positive slope. And this is just basically because we start from our leftmost point always, and our leftmost point here, in the case of this line you're viewing right now, is over here, and it's actually going down from that point. So we know the slope is negative because of that, because the line goes down. But over here, our leftmost point is just starting from here, and it's actually progressively going up. And that's how we know the slope is positive. So in the case of what we've got for this question, we got -3/4 as our slope. So we know for sure that our line is going to be going down. And using this information, and as well as the information I'm going to provide you in a bit, we can actually easily plot our points. So taking a look at our slope here, we have -3/4 as our slope. And remember how I mentioned before about rise over run, and slope is actually the change in y divided by the change in x, or delta y over delta x. And that's exactly what we're going to be thinking of when we plot these points. We're going to be thinking of the change in y divided by the change in x. And as you can see, I said slope was the change in y over the change in x. That's actually the case with this question. This is the change in y, -3 is the change in y, and +4 is like the change in x. So we're going to be plotting that right now. So change in y is -3. So from the y-intercept, this blue line here that we have plotted, I'm going to go down 3 units, because keep in mind there is a -3 there. So going down 3 units, 1, 2, 3, I've landed at the origin, and we're going to go right 4 units, 1, 2, 3, 4. And that's just plotting it right here. And now I'm just going to do this one more time. Take a look at what you have on your numerator, which is the change in y. Since this is negative, we have to go down by -3 units. But if this was just 3 over 4 as a slope, we'd go up 3 units. But since it's negative, we're going to, the change in y is -3. So 1, 2, 3 over here over the change in x, which is 4 units. So from there, 1, 2, 3, 4. So that's right over here. I'm just going to extend this line a bit so we actually get those points, and 3, 4. So see, that's about there, and that's approximately where I have drawn my point there. So we have the change in y over change in x, and using that, we've just plotted our points, and I'll just do one more here. Here we have, since we don't have any space here, we can try going up, and I'll do this by, I'm going to be starting from y-intercept, and I know that change in y over change in x is indeed our slope, and change in y is -3 and change in x is 4. But since we're going to be going this way, we can actually reverse it because we know that the line needs to go somewhat like that based on what we have so far. So we're actually going to be doing this. We're going to be starting from y-intercept again, going up 3 and going left 4. But since we're going left 4, this actually represents negative still. So as you can see, we have now found our line. And we can just connect all these points. And one more thing, when you connect these points, don't forget to put these arrowheads at the end of each point of your line, because a linear graph, or mostly any graph for that matter, will always extend to an infinite amount, will also always be going on forever, and that's just the case with this line as well. This line will always be extending forever, so you just want to put those arrows on either side of the line to indicate that. So now here we have it. This is our answer because we were told to graph the equation of 3x plus 4y equals 12, and we just put that into slope-intercept form, located the y-intercept, and then found the slope, and then we knew that it was change in y divided by change in x, and we went up by however many points the change in y was, and right or left depending on where your position of your line was for change in x. And there we have it. This is how you graph a line like this. All right, so now we're going to be moving on to our last and final problem, which will be on multiplying polynomials. So keep in mind, I'm only going to be doing one question right now on multiplying polynomials. I'll be just going over a brief example, but keep in mind that I actually have another webinar coming up on multiplying polynomials, an actual webinar on that, which will go more in depth into these kinds of problems and also be introducing a bit more complex concepts, as well as more in-depth and more variations of those kinds of multiplying polynomials problems in that webinar. So if you are interested, please feel free to check our website in order to gain information for that particular webinar. So for now, I'm just going to quickly be demonstrating to you one quick example on multiplying polynomials. So multiplying polynomials, our question, which I'll be showing you how to do today, is 4n plus 6 times 8n plus 8. So as you can see, these are polynomials, and we are just multiplying them simply. But since there are basically like a set of polynomials, two different polynomials in brackets, we actually are going to be applying our distributive property here. And if you are not too familiar with what distributive property is, that is just basically taking your first term inside your bracket and multiplying it with each term, multiplying outer brackets, multiplying with each term in the other bracket. And similarly, we're going to take 6 here and multiply it with each term in the other bracket. So I'm just going to show you how this is done. So first, we're going to be taking a look at 4n, and we need to multiply by the first term in the other bracket. So 4n times a to n is 32n squared, because 4 times 8 is 32, and n times n is n squared. So 32n squared is the product of those two. In addition, now we need to do 4n times 8, which is 32n. So I'm just going to write this down. And then next, we're going to take a look at this 6 here, and we're going to be distributing it with our brackets. 6 times 8n, which is 48n. And finally, we have 6 times 8, which is the second term inside the second set of brackets. And we have 6 times 8, which is 48. And now we need to further simplify and gain our final answer. So we have 32n squared here, and now we have 32n plus 48n. We can combine like terms here, and adding these, we have 32n plus 48n, which is 80n. So 80n plus 48 there. And therefore, this is our final answer to the question 4n plus 6 times 8n plus 8. And this is just a quick sneak peek or example of what multiplying polynomials is, and another example on it. And if you would like a further in-depth teaching on how to do these kinds of problems, as well as more variations on these kinds of problems, as mentioned before, please feel free to check our website, as I am going to be doing a webinar specifically on the topic of that. All right, so I just wanted to take this opportunity to thank all participants from around the world for joining us today for today's webinar. I hope you enjoyed and was able to take away something new and useful from today's session. And just another friendly reminder that this session is recorded and will be posted to our website shortly after this session. The link to our website is pasted in the chat and is also displayed on the screen you are viewing currently. And in addition, our next webinar will be on July 18th on the topic of solving system of equations with 3 variables. So if you are interested, please check our website on information on how to register for that webinar. In addition, keep in mind that these sessions are free, so if you know anyone who's interested or would benefit from these sessions, please let them know so they may register for the sessions as well. And once again, my name is Arya Peruma. Thank you so much for attending today's webinar, and I hope to see you soon. Thank you and bye.